Hello, jirtu hordoftoonni KOOKEEF-TUBE akkam jirtu bakka jirtanitti nageenyi keessan isiniif akka qabu jecha OR or Operational Research Course jedhu barattoota Business Management fi Business Administration warroota ta'aniif hojjechaa turre boqonnaa jalqabaa fi boqonnaa lammaffaa paartii afuriin hojjennee turre har'a immoo boqonnaa sadaffaa the Post-optimality Analysis and Duality in Linear Programming kan jedhu hojjechuu barbaanne boqonnaan kun baay'ee barbaachisaadha garuu gabaabsinee har'uma xumuruu barbaanna san booda boqonnaa afuraffaa transportation and assignment problem kan jedhu yeroo baay'ee exam irratti illee kan dhufu isa waan ta'eef isas kan ilaallu ta'a chapter 2 fi chapter 4 yeroo baay'ee exam irratti happen ta'a barattoota management business management akkasumas business administration dhaaf kanaaf isa sanarratti xiyyeeffannaa har'aaf garuu post optimality analysis and duality problem kan jedhu kana ilaaluun baay'ee barbaachisaa waan ta'eef isa ilaalla barattoonni channel keenya faaraa taatan channelicha subscribe godha viidiyoicha immoo like godha barattoota akka keessanii kan viidiyoo kana barbaadaniif immoo share gochuudhaan channelicha akka guddatu taasisuu viidiyooichi immoo akka ijoollee bira qaqqabu taasisuun gahee keessan akka baatan isiniin affeeruu barbaada warroonni haaraa taatan kana yoo goota warroonni durumaayyuu channel kana hordofaa turtan immoo kan isin darbe yoo jiraate gara duubatti deebitanii Operational Research Introduction Part Chapter jalqabaa fi Linear Programming Problem and Solving Linear Programming Problem kan jedhu boqonnaa lammaffaa ilaaluu ni dandeessu jechuun barbaada har'a kallattimaan gara Sensitivity Analysis kan jedhu kanatti kan ceenu ta'a jechuudha. Post-optimality Analysis and Duality in Linear Programming gaafa jennu maal jechuu keenya maaliif nu barbaachisaa what the aim of Post-optimality Analysis kan jedhu ilaalla dura garuu let see sensitivity analysis. So what mean by sensitivity analysis and what the purpose kan jedhu ilaalla. So in chapter 2 while solving the linear programming problem for optimal solution we assume that one technology is fixed. Yes, yeroo linear programming problem is solve gof goonu whether graphical method or the simplex method technology is fixed jennee assume the technologies fixed jenneti kan nuti solve gochaa turre inni biraa immoo fixed price even the price is not varied akkasumas the fixed level of resource or requirements and the coefficient of variable in the structural constraint meaning the time required by the product on a particular resource is also fixed and the profit contribution of the product will not vary during the planning period jechaa turre jechuudha naaf parameteronni kunniin kanneen akka technology price akkasumas coefficient of variable profit contribution isaan kunniin they are fixed jedha assumption kana fudhanneeti kan nuti linear programming problem solve gochaa turre karaa adda addaati this assumption implying certainty yes assumptiononni kunniin maal nutti himu certain akkasumas complete knowledge in the static condition yes fixed condition jechuudha static condition jechuun akkasumas permit us to design and the optimal program kanaaf assumptiononni kunniin certain dha complete knowledge qabna akkasumas static dha jenneeti kan nuti fudhachaa turre the condition in the real world amma gara addunyaa dhugaatti gaafa dhufni garuu might be different from those of the assumed model amma assumption keenya irraa addunyaatti gaafa dhufnu garaagarummaa guddaa qaba fakkeenyaaf technology fixed miti technology yeroo yeroodhaan jijjiiramaa deema jira akkuma isin beektan inni biraa price it is not fixed price can be varied depending on different thing akkasumas the coefficient of variable and structural constraint like time it is not what fixed miti and the so called profit contribution is not again fixed so if it is therefore a desirable to determine how sensitivity is the optimal solution is to different types of change in the problem data and the parameter kanaaf digtani ega parameteronni kunniin fixed in tan yote in real world or in the real market kanaaf sensitivity analysis hojjechuu qabna sensitivity gaafa jennu optimal solution in kuni hammam deviate gochuu danda'a jijjiiramuu danda'a sababa technological variation itiin sababa price itiin sababa coefficient of variable in jijjiirameen yes sababa profit contribution in jijjiiramuuni hammam fixed ta'a kan jedhu sana sensitivity analysis hojjenna jechuudha so this sensitivity analysis indicate that how much optimal solution can be varied based on the change in constraint. Change in constraint. So when you come to the change in the right hand side value of the constraint, so determine how change in the right hand value of the constraint that would influence the optimal solution jedha. Ega right hand solution kana argachuudhaaf immoo step on nuti hordofu qabnu jira. Step inni jalqabaan ega examine the shadow price in the final simplex tableau of the optimality analysis jedha. Shadow price jechuun immoo maal jechuudha kan jedhu ilaalla. So the first step in jalqaba garuu shadow price kana in the final simplex tableaus irra jiru sana examine gochuudha. So shadow price mean that or shadow price are the coefficients of the slack variable in the z row of the final the so-called simplex tableau. So simplex tableau sana irratti z row irratti variable in slack variable in jiru kan coefficient in slack variable sana irra jiru suni maal jennani the so-called shadow price jennan jechuudha. So shadow price is a marginal value. It indicates that the impact that a 1 unit change in right hand value of the problem constraint would have on the value of the objective function. Yes, objective function keenya irratti the right hand value of the constraint kanneen jedhaman isaanan sunniin gaafa vary goonu objective function irratti yookaan optimal solution for objective function irratti hammam jiramni kennu kan fiduu danda'u kan jedhu kan itti himudha jechuudha. So shadow price reveal the amount by which the value of the objective function would increase if the level of the right hand value of the given problem constraint was increased by 1 unit. So again, shadow price do not tell us the extent to which the level of the scarce resource can be changed and still have the same impact per unit. Amma shadow pricing kuni level of resource or level of scarce resource kana nutti himu jechuudha. Waa'ee kana nutti himuu hin danda'u. Again, we need to determine the range over which we can change the right hand value quantity of the problem constraint given that there is the same shadow price, and this range is called range of visibility or the right hand side range. So range of visibility gaafa jennu optimal solution in suni visibility ni maal fakkaata kan jedhu kan nutti himudha. Kanaaf the so-called shadow price can be tell about this as well. Sannan kan hunda nutti himuu danda'a. Kanaaf step inni jalqaba akkuma asitti ilaalle examine the shadow price in the final simplex tableau of the optimality analysis. Inni lammaffaani construct the range of visibility for construct the range of visibility for each and every right hand side value of the existing constraint of the linear programming model. Here the key to computing the range of visibility for the constraint lays in the final simplex tableau of the optimal analysis. Almost simplex method of solving linear programming problem kanneenidhaaf fayyada jechuudha. Technique kun the so-called analysis kun sensitivity analysis yeroo baay'ee for simplex method idhaaf fayyada. Kanaaf step lammaffaratti wanti nuti goonu range of visibility area constraint goona jechuudha. Sana booda the key computing the range of visibility for the constraint lays in the final simplex tableau of the optimal analysis jedha. Purposely the entries in the body of the final simplex tableau in each slack column must be used to compute the range of visibility for the corresponding constraint jedha. Step lammaffaratti egaa kan infa determine godha. So informing the range we need to consider the following jedha. Range sana form gaafa goonu consideration nuti galchinu hedduu jira. Tokkoffaa the entry in the associated slack column should be identified. Yes, entry 1 slack column sana keessatti galchinu san tokkoon isaanii sirriitti adda baasnee beekuu qabna. Inni lammaffaa the ratio of the current value to the corresponding entries of the slack column should be determined. This would be carried out when the entries in the associated slack column have been divided into the corresponding value in the current column jedha. Egaa ratio of current value to the corresponding entry of slack column sana maal gochuu qabna determine gochuu danda'u qabna jechuudha. Egaa slack column keenya entry dhaan adda baasnee booda yookaan entry to identify goone booda ratio isaa immoo calculate gochuun nurra jiraachuu danda'a jechuudha. Then the lower and the upper limit of the range should be determined. Yeah, range jennaan there is upper and the lower limit wanta jedhamutu jira. Kanaaf garaagarummaa isaan jidduu jiru immoo yookaan immoo isaan lamaan sana adda baasuun irra jiraachuu danda'a. Fakkeenyaaf for maximization problem lower limiting keenya current level of the constraint ta'u to minus the positive ratio near to 0 touch. So lower limit is equal to current level of the constraints minus the positive ratio nearer to 0, and upper limit gaafa jennu immoo current level of the constraint minus the negative ratio. The negative ratio asitti immoo positive ratio. Kanaaf lower limit and upper limit keenya gaafa maximization problem idhaaf solve goonu bifa kanaan jechuudha. Current level of constraint keenya beekuu qabna. Isarraa positive ratio nearer to 0 yookaan immoo negative ratio nearer to 0 sana irraa hir'isna jechuudha. Yoo minimization problem ta'e immoo lower limit keenya current level of the constraint minus the negative value, almost reverse actually. So for the lower limit you have to use negative ratio, but for the upper limit you have to use positive ratio fayyadamna jechuudha. Almost kana wajjin gaafa ilaaltan positively fakkaatu jechuudha. Positively fakkaatu. Kanaaf sensitivity analysis bifa kanaan erga adda baasuu dandeenya jechuudha. Example given below an example in nukenamera. So given below is the linear programming model and the associated final simplex tableau of optimality analysis. Identify the shadow price and determine the range of visibility. Yes, ega problem in Kenya nukenamera, the so-called maximization problem. So z is equal to 3x1 plus 4x1. This one is our objective function. Yes, this objective function. Now here is the constraint 3x1 plus 5x2 less than or equal to 50, 2x1 plus x2 less than or equal to 8, x2 less than 2, and the all variable is greater than or equal to 0 or positivity or non-negativity of the constraint. Now for this problem you have to identify the shadow price and determine range of visibility. Shadow price fi range of visibility sa adda baaf. Kana gochuudhaaf akkuma beektan asin duras waan gochaa turre waan ta'eef chapter 2 irratti simplex tableau irratti maal goona baafna jechuudha. There is a basics x1, x2, s3 and x2, and there is a column and there is c is a column are there. So here is x1, x2, slack variable jennaan intri s1, s2, s3 ganni sanan kunninis value bifa kana erga kennine booda now you have to write your value each separately like this. Now here is the quantity. Yes, here is the quantity. Alif gaafin keenya wanti nuti gaafatamne find the shadow price and determine range of visibility waan ta'eef erga bifa simplex tableau kanaan akkatti erga adda baafne booda you have to go to the solution. Now the shadow price are entries along the row Z which fall under the 3 slack variable. Shadow price in Kenya, the entry along row Z which fall under 3 slack variable S1, S2 and S3. These value are 0.714, 0.428 and 0. Can I choose almost is a can I choose 0.41 14, 0.428 and 0. Bifa kanaan slack variable keenya irratti value argannu kana laallako. So now the shadow price are this value 0.414 is a marginal value. It indicates the impact that a unit 1 unit change in the right hand side value of the first problem constraint would have on the value of the objective function. Yeah, this is the value of an objective function. Kanaaf value one sadeen kennaman kana keessa shadow price sadeen kennaman keessa lakkoofsi inni guddaan kun kan indicate what the marginal value of our objective function. So that is the value of the objective function would be increased into this plus this one, that is if the level of right hand side value of the first problem constraint is increased by 1 unit jechuu barbaadeti kuni. Exercise jedhee analyze on the right hand side of the second and third constraint jedha. Isin immoo kana suuta jettanii adda baasuu ni dandeessu jechuudha. Inni biraa the change in an objective function coefficient table. Objective function keenya immoo coefficientota isaa change gochuu dandeenya jechuudha. So it is useful to know how much the contribution of a given decision variable to the objective function can change without changing the optimal solution. Kanaf, how much the contribution of the given decision variable to the objective function we use it with can change without changing the optimal solution. Kan jedhu kana iddoo itti beeknudha jechuudha. The changing objective function coefficient gaafa jennu. So here are we have to consider two cases. Keezota lamaan kana mee consider agoonu. Keeziin inni jalqabaa change for the coefficient of decision variable that is not currently in a solution mix kan jedhu kana jechuudha. Almost is non-basic decision variable kan jennudha. Egaa keezonni lamaan basic decision variable fi non-basic decision variable kan jennudha. Egaa akkuma argaa jirtanitti the change for the coefficient of the decision variable that is not currently in the solution mix. Inni kun non-basic decision variable. Inni lammaffaa change for the coefficient of decision variable that is currently in the solution mix. Kana jechuun basic decision variable jechuudha. Basic decision variable. So the change for the coefficient of decision variable that is not currently in the solution mix or non-basic decision variable gaafa jennu asitti maaltu jira? Maybe range of insignificance hin jiraachuu danda'a. So this range of insignificance associated with if the decision variable is not currently in solution mix in maximization problem, its coefficient in the objective function would have to increase by an amount that exceed its corresponding value along the Z row in the final simplex tableau in order for it to end up as a basic variable in the optimal solution mix. Egaa range of insignificance bifa kanaan ilaalamuu ni danda'a. Inni biraa that is in order for the variable to be included in the optimal solution, its coefficient in an objective function will have change from the existing coefficient to the new coefficient itti geeddaramuu qaba. Inni biraa immoo the new coefficient level should always exceed the corresponding value of the non-basic decision variable along the row so-called Z row jechuudha. Inni kun immoo new coefficient of level gaafa include goonu inni sun immoo non-basic decision variable along with Z row sana correspond gochuu danda'a jechuudha yookaan qaba jechuudha. Inni biraa hence the range over which the coefficient of non-basic decision variable in an objective function can change without causing the optimal solution of the basic decision variable is said to be range of insignificance. Range of insignificance. So the range of insignificance means that the range over which the coefficient of non-basic decision variable in an objective function can change without changing an optimal solution of the basic decision variable. So the upper limit of such arrangement is given in the Z row under non-basic decision variable column, which is 0 is less than Cj, which is less than Zj. Cj almost it is a new coefficient of the J's non-basic variable. Zj is the corresponding value of the J's non-basic decision variable along with Z row jechuu akka ta'e nutti himaa jechuudha. Asitti example nu kennameera. Example kana immoo laalla. So given the final simplex tableau, determine the range over which the coefficient of non-basic decision variable in the objective function could change without changing the optimal mix. Egaa final simplex tableau kana nu kennee jira. Amma range over which the coefficient of non-basic decision variable in an objective function could change kan jedhu sana iddoo itti barbaadnudha jechuudha. Kanaaf there is a basics, there is Z and there is C minus Z row are there. So isaan kunniin asin immoo x1 x2 x3 s1 s2 s3 fi quantity isa gadi almost nu kennamee jira jechuudha. Kanaaf x1 x3 in the s3 and C isaan immoo asin kennameera x1 x2 immoo akkuma argaa jirtan nu kennameera Z din keenyas bifa kanaan kennamee jira. C minus Z dinis bifa kanaan already kennamee jira. Kanaaf amma kanarraa maal barbaadna jechuudha? Range barbaadna jechuudha. Range barbaadna. So because jennaga x2 is not in the solution mix, because x2 is not in a solution mix, yes, x2 is not in a solution mix, x2 there is no in a solution mix, x2 is not in the solution mix. it is coefficient in the objective function would need to increase in order for it to come into a solution. Yes, this coefficient in isa mal ta'u qaba, coefficient in objective function isa dabalu yookaan immoo increase ta'u qaba jechuudha, gara solution itti include ta'udha. The amount of increase must be greater than its corresponding value along the row C minus Z, which is 0.842. Yeah. Yes, we are speaking about this one. We are speaking about this one. So 0 to 8 target amount of increment. Therefore, sakana all ta'u qaba. Therefore, its existing coefficient in the objective function must be increased by more than this number. Kana all ta'u irra jira jechuudha. So because its current value is bir 4.5, the current solution will remain optimal as long as its coefficient in the objective function does not exceed bir 4.5 plus 0.842 or 5.342. For the reason that an increase would be needed to bring it into the solution mix. Any lesser value than 5.342 of its coefficient in an objective function would keep it out of the solution mix, and hence the range of insignificance of x is around 5.342 or less. That is less than C2, or new C2 is less than this one. And however, that in order for the variable to be included in our optimal solution, its coefficient in the objective function will have to change from the existing coefficient, so-called 4.5, into a new level which would exceed the corresponding value of this variable along row Z, which is 5.342 jechuudha. Gaafa walitti hidhamu kan isa kana jechuudha. Isa kana exceed ta'uu danda'u qaba jechuudha. Therefore, the change for the coefficient of decision variable that is currently in a solution mix or basic decision variable kan jedhamu kan reefu non-basic decision variable ilaalla jechuudha. Range of optimality, so range over which the coefficient of the basic decision variable can change without shifting the optimal solution of the basic decision variable is called range of optimality. So range of optimality is it is what the value that is shifting the decision value, the decision variable without changing the optimal solution. So for the variable which are in a solution mix, the determination of the range of optimality requires the entries along the row C minus Z and the corresponding row value of the basic decision variable in an equation in the body of the final simplex tableau. And in order to determine or in order to form the range of optimality, one has to carefully consider the following event data. The entry along the row should be identified. The value in this must be divided by the corresponding row value of the basic decision variable in an equation, and they will result in a series of ratio plus their positive ratio, especially closest to 0 will indicate the amount of the allowable increase to the current value, and the negative ratio closest to 0 will indicate the amount of allowable decrease from the current value. Inni kun meaning isaadha jechuudha, interpretation isaadha. Value isaa erga arganne booda value sana bifa kamiin akkamitti interpret akka goonu nutti himaa jira. Finally, the lower and the upper limit of the range should be determined according to this rule. Applies for both maximization and the minimization rule. Lower limit is equal to existing coefficient of the basic decision variable in the equation plus the negative ratio nearer to 0. Upper limit is existing coefficient of the basic decision variable in equation plus the positive ratio near to 0 kan jedhu sana ilaaluu dandeenya. Asittis example biraa nuuf dabalaa jira. So determine the range of optimality for the decision variable in a solution mix jedha. Egaa objective functioning keenya nu kennameera, the so called maximization problem ila. So maximize z is equal to 12x1 plus 10x2 plus 15x3 plus 11x4 jedha. The subject to jedhe ABC nu kennameera 5x1 plus 3x2 plus 4x2 plus 3 plus 2x4 less than or equal to 214 and 6x1 plus 8x2 plus 2x3 plus 3x4 less than or equal to 214 2x1 plus 3x2 plus 3x3 plus 2x4 less than or equal to 180 dha. Inni kun for those of material, inni kun for machine, inni kun for those of labor. Kanaaf isaan kunniin constraint dha jechuudha. They are subject to jedhe taanani constraint nutti himaa jira. Kanaaf all variables greater than or equal to 0. Inni kun immoo it can indicate the non-negativity of the so-called constraint kan jedhu sana nutti himuu barbaadeeti. Amma gaafiin keenya maa inni determine the range of optimality for the decision variable in a solution mix. Kanaaf kana solve gochuudhaaf dura the optimal simplex tableau keenya baafachuu danda'u qabna. Akkuma beekamu this is basics. It can be given like C and that coefficient can be written like this one. S1, S2, S3 isaan kunniin they are slack variable jennani. Quantity isaan immoo asitti nu kennamee jira. Now the C, X1, X2, X3 up to X4, X3, S1 and the X4 can be written like this, and the Z can be written 12.8, 80.6, 15, 11, 0, 0.6, 4.6, and 972. C minus Z dinimo bifa kanaan nu kennamee jira. Now range of optimal value kanarraa barbaanna jechuudha. Now for the variable which are in the solution mix, the determination of the range of optimality requires the entire along the CZ. Reefu range of value range barbaada turre. Amma garuu kan nuti barbaadaa jirru range of optimality dha waan ta'eef C minus Z row sana keessa barbaadna. And the corresponding row value of the basic decision variable in equation in the body of the final simplex tableau jechuudha. Garaagarummaa qaba range in the range of optimality. Kanaaf reefu Z kanarraa kan nuti barbaachaa turre amma immoo C minus Z row kanarraa barbaadna jechuudha. So now the analysis of the coefficient of x3 in the objective function. Yes, the so-called x3 jechuudha. C minus Z isa bifa kanaan erga barreeffamuudha. X3 meaning C minus Z over x3 isa value isa bifa kanaan kennameera waan ta'eef maal ta'a gaafa jennu the value is like this. The value is like this. Yes, 0 over 0 0 over 1 is 0, 0 over 0 is undefined, 0 over 0 undefined. It is simple mathematics ida waan ta'eef kun 0 over 0 jechuu hin dandeenyu, 0 over 1 jechuu garuu hin dandeenyu, 1 over 0 jechuus hin dandeenyu. Yes, mathematics ida kana egaa hin beektu jedheeti yaa tokko irra 0 jechuu hin dandeenyu, undefined 0 irra tokko jechuu garuu ni dandeenyu. Akkasumas 0 over 0 jechuus hin dandeenyu. Kanaaf bifa kanaan erga arganne booda gara maalitti deebinaa kallattimaan the lower and the upper limit keenya barbaanna jechuudha. So the lower and the upper limit of the range of optimality covers which coefficient of the basic decision variable for x3 can change in and obtained to be the lower limit is equal to 15 plus 7.67. Yes, this is negative. Yes, or minus. Yes, this value is obtained from this table, I think. Yes. Yes. The lower limit is equal to 15 plus negative 7.67. That is almost 7.33. This indicates that the coefficient of can be decreased by 7.67 before its unit the lower limit of the range of optimality. The upper limit in Kenya mu ida'u ta'a. Inni immoo 15.67. This indicate the coefficient can be increased by 0.67 before it reaches the upper limit of the range of optimality. Therefore, 7.33 less than or equal to X or C less than or equal to 15.67 is said to be the range of optimality over which the profit per unit of the product can be product 3 can be valid. Kanaaf range of optimality fi range gaafa barbaannu bifa kanaan barbaanna jechuudha. Bifa kanaan barbaanna upper limit and lower limit keenya erga barbaanne booda for what the product 3 da for product 3. Now when you use the analysis of the coefficient of x4 in an objective function isamu yo fudanne also x4 kana fudanne jechuudha. Yes, so isa fudanne immoo cz minus x4 ta'a jechuudha. Yes, maal tu ta'a. Now the lower and the upper limit of the range of optimality for which the coefficients of the basic decision variable in an objective function can change it is found to be jade a lower limit is equal to 11 plus 0.29 minus 0.29 mean this one. Yes, kubsa kana jechuudha. Equivalent to jade is 10 point something that this indicates the coefficient can be decreased by per this before it reaches the lower limit of the range of optimality jechuudha. Upper limit gaafa jennu immoo it can be 11 plus 11.5 that is 22.5. This indicates the coefficient can be increased by 11.5 before it reaches the upper limit of the range of optimality. Inni kun for product isa kana fudhachaa kan jiru inni 11.5 jechuun isa 11.5 jechuun isa sana. So 11.5 jechuun karaa saniin ilaalama jechuudha. So bifa kanaani range of optimality barbaaduun ni danda'ama. Lakin isa dhumaa boqonnaa kana jalatti duality linear programming problem kan jennudha. Egaa there duality gaafa jennu isa dual jechuun two dha ni beektu. So in linear programming problem it exists in pair jechuudha. So linear programming problem exists in pair that indicate the duality of linear programming problem jechuudha. Dandeenya that is in the linear programming problem every maximization problem is associated with minimization jechuudha. Itani maximization problem ni yoo jiraate it can also associated with the so-called minimization. Maximization and minimization comes together in pair, so it indicates duality. Conversely, associated with every minimization problem is also maximization problem. Once we have a problem with its objective function as a maximization, we can write by using duality relationship of linear programming problem. It is minimization version. Yes, and then the original, the so-called the original linear programming problem is known as primal. Inni jalqaba primal jennani derived problem immoo dual jennan jechuudha. Kanaaf dual and the primal can go together, therefore linear programming problem is said to be duality or dual jennan jechuudha. Fakkeenyaaf here is a primal problem, the so-called minimization, and here is a dual problem, the so-called maximization with this constraint jechuudha. Sannan kunniin constraint jechuudha. This is standard form of the minimization problem and the standard form of the maximization. The primal or the first linear programming problem we can drive the dual so-called maximization problem. Inni kun as primal kenname taana inni kun immoo as dual ta'a jechuudha. Egaa bifa kanaan ibsamuu ni danda'a. Boqonnaa afuraffaa egaa transportation and assignment problem kan jedhu yeroo biraa qabannee kan dhufnu ta'a. Har'aaf boqonnaa sadaffaa bifa kanaan xumurree jirra. Thank you very much.